At this point, you're probably left with a puzzling question, which is why Hyperlambda and why is it so weird? Now, in order to answer that question, I need to show you some features of Hyperlambda. Now, of course, the short answer to that question is arguably summed up in Aista's slogan, which is where the machine creates the code. However, what does that really even mean? In this video, we're going to dive into that question and actually answer that question. So go to your Cloudlets and Expand Tools, go to SQL Studio, and let's create a new database. You can just close this plugin thing if you have it. As you can see here, we only have one database. Click these three dots here and choose New Database. And let's call our database Code. So we now have a new database. Let's create one table in our database by clicking the second three dots down here and choose Add Table. And let's call our table Snippets. Click Tab, remove the S to be semantically correct, to get the name of the primary key correct, and click caret return. We now have a table called Snippets in the database called Code. It has a primary key called Snippet ID. Now we want to add a field to this table. So click these three dots here, choose Add Field Key, and give your field the name of content. Choose data type text, remove the nullable parts here, and click Create. We now have a mandatory field in our snippets table called content that is of type text. Expand your MISC folder and go back to the evaluator that we were using in our previous video. Now, and then inside of this evaluator, we are going to be writing some interesting Hyperlambda. First, let's get some space here and then write http dot and click control space on Windows or function control space on a Mac, to which point we're given autocomplete for every single slot in the system that starts with the text http dot. So you can see we have HTTP delete, get, patch, post, and put. And the same way, just like we created an HTTP endpoint in our previous video, we can actually invoke any HTTP endpoint using Hyperlambda. So what we're going to be using in this particular tutorial, we're going to be using the http.get keyword. So make sure you mark http.get, click caret return, write colon, 2 double quotes, and then write https://aista.com. Obviously, this is the URL to our primary landing page at aista.com. If we execute this by clicking F5, you can see the result here. Here we have a status code of 200. We have HTTP headers collection. Then further down here, we have the content being basically the HTML of our landing page. Now, let's create an if statement. Our if statement is going to look like this. If caret return tab EQ. EQ is a keyword in Hyperlambda. It means equals colon x colon at http.get caret return tab dot colon int colon 200 caret return shift tab to de-indent dot lambda caret return tab log dot info colon aista.com seems to be fine. Caret return shift tab twice else caret return tab log.error colon aista.com is not okay. Now, of course, if we evaluate this for those having some software development experience from before, it might be quite obvious what this particular Hyperlambda snippet does, but basically, let me walk you through it. It gets the HTTP document at aista.com, then it does a comparison if the status code of this HTTP get invocation equals 200, execute this Lambda object. This Lambda object logs to our server log an info type of log entry. Else, implying it's not 200, anything but 200, it logs an error. We now execute this code, F5, and then we open up our log in a different browser tab. We will see aista.com seems to be fine. Now, we can just keep on executing this. However, that's not what we are going to do. Because what we are going to be doing, we are going to show some of the dynamic features of Hyperlambda and the reasons why we can confidently say where the machine creates the code. So go to the top of this file, add another line at the top, write .lambda. and then mark all of this code from line 2 and all the way down, click tab. This indents the entirety of the code that you have selected. We now have a Lambda object, and actually this Lambda object doesn't do anything. If we execute it now, you will see there's nothing here. Why? Because we're actually not executing the Lambda object. We could write eval, which basically means evaluate Lambda, :x, @, dot Lambda, which point when we click F5, we will see that now it's actually executing the HTTP GET invocation because it's executing this Lambda object here. However, we don't want to evaluate it. We want to instead transform it into a string. Lambda to hyper :x, @ dot Lambda /*. This is where it becomes interesting, because when you now click F5 and you execute this code, you will now see that you have a string. Now we can do interesting things with a string, right? And we just so happens to have this beautiful database we created 5 minutes ago that allows us to insert strings. So let's do that. Instead of executing the code, we are now going to insert that code into our database table. So write data.function control space or control space on Windows, choose data.connect, : code, carriage return, tab, data.function control to get autocomplete, creates a database record, carriage return, tab, table, name of our table is snippets, plural form. Then we are going to insert into this table the following values. There's only one, but the name of the segment is values, plural form. Carriage return, tab, content is the name of our field, : x, @ Lambda to hyper. And now, if we execute this code now, function F5 on Mac and F5 on Windows, and then we open up tools and open up SQL Studio in a different browser window, and we close this guy, and then we choose our code database, and we write select all from function control space, autocomplete, control space on Windows, choose snippets, and we execute it. We will now see that we have a piece of Hyperlambda inside of our content. We have one record in our snippets table in our code database that contains a bunch of Hyperlambda. And it's not correctly formatted, but if you click this, you will actually copy it, at which point you can, go down here at the bottom, paste it in, and see that it's actually correctly indented, right? And this allows us to keep on inserting snippets. Let's do dsound.com. dsound.com and execute the code. Then let's do actually let's do microsoft.com, function F5 to execute. We've now executed this thing 3 times, so if we now go back to our SQL Studio F5, we will see we have 3 records returned, right? And all of these records are kind of like checking if some URL is okay or not, right? That's their purpose. Now, what we want to do, we want to save this code, and we want to call it tutorial-02 second video -01 first snippet in the second video. Click save, just to keep it as a reference for the future. Now we have a bunch of Hyperlambda in multiple records in one database. So let's use that fact to something intelligent by, first of all, just deleting all of this code, and then let's write data.connect, : code, same database, carriage return, tab, but this time we don't want to do create, we want to do read, carriage return, tab, table, : snippets, carriage return, columns, which columns we're selecting, carriage return, tab, and we want content. If we execute this now, we're basically just getting every single content record from our snippets database, right? And this could be 1 or it could be 100. If it's more than 25 for the record, you need to apply limit : -1. Because by default, for security reasons, the data that read invocation only returns the first 25 items. You might want to add a limit : -1 at the bottom here, the way I just did now. Now, let's create a Lambda object. .lambda. Right? Now we want our Lambda object to be empty because we want to populate it dynamically. The way we would do that is that we would do add : x, @ dot Lambda. Then we want to write hyper to lambda. This is the opposite thing of the lambda to hyper. The lambda to hyper takes a graph object and turns it into a string. The hyper to lambda takes a string and turns it into a lambda object. If we now execute this code, it won't work because we need to iterate. So we need a for each loop above :x at data.read /**, and then inside of here we want to tab and indent this code. Then the expression we're passing into hyper to lambda should be :x at .dp /hash. If we now execute this code, something interesting is happening. You see, now we have basically copied and pasted every single string by transforming it to a lambda object and creating one aggregated function from multiple snippets of Hyperlambda. And that is pretty cool, because with Hyperlambda you can take half a function, or you can take multiple functions and combine them, or you can take one function and inject into one specific position of another function. And since absolutely everything is functions, because Hyperlambda is a functional programming language, this allows you to modify your code the same way you would modify a JSON object or a YAML file or an HTML document object, model, thing, etc., etc. Now we can eval :x at .lambda. At the bottom here, we can execute the code. We can go back to SQL Studio, open it in a different tab, and we can see, sorry, not SQL Studio, but we can see the log. And we can see Microsoft seems to be fine, this one seems to be fine, Ista seems to be fine, and they were all executed within 1 second apart. Now let's save this snippet such that we have it for later. Call it tutorial -02 -02. Why? Because it is the second snippet we are saving in the second YouTube video. Click save, and then we're done here. Now we're gonna do something else, because we have now seen how to create one function as the aggregated result of multiple functional objects. What we're going to do now is that we're going to take existing Hyperlambda files and we're going to modify them dynamically by actually creating a computer program that actually maintains our code. However, before we can do that, let's go to our go to Tools, click Plugins, and let's install a database. Why? Because we need a database in order to create a CRUD API, and in order to actually create code that modifies code, we want to have a bunch of files. Now I can choose, for instance, the Northwind DB. Let's just click Install on Northwind DB here, and this is going to take some seconds because it's downloading a huge SQL DDL script that creates our database and populates it with some default records, etc., etc., and all that good stuff. Now, however, when this is done, we actually have a database. So if we go to SQL Studio now and we select Northwind, then we can actually already at this point select all from, and we see we have a bunch of tables, categories, etc., etc. We can select the records from this database. You can click the 3 dots here and close the result. And you can also see the schema of this particular database. This is the design of the database, and you can actually modify it as you see fit and add key fields and whatever to it, the way you see fit. However, what we are going to do, we're just going to take this database as is, click the CRUD generator, then we're going to choose this database, Northwind, and then just simply click CRUDify all tables. Why? Because this creates a bunch of Hyperlambda files for us. So if we now go back to HyperID, expand modules, we expand Northwind, then every single file inside of this folder was actually dynamically created by the CRUD API generator. And if you open any one of them, you will see that it's doing auth.ticket.verify, passing in string of root, comma, admin. Now let's say we had 1,000 files that were exactly like this. However, we wanted to change every single file. Now, we could either spend like a week manually editing our files, or we could create a computer program that actually automatically maintains our code. So let's do the latter. Obviously, that is slightly more intelligent than the first choice. So let's go to our MISC and our evaluator. And at this point, we're going to use a predefined snippet. If you click load here now, you scroll a little bit down, you will find a snippet that's called format Hyperlambda. Click this loads the script. and then let's start editing the script. Now we want to take our module here, so we want to type Northwind, like this, such that the complete folder becomes basically /modules/Northwind/. And that happens to be the name of our Northwind module. Then it's listing files recursively inside of that folder. Then it's iterating through each file. Then it's checking to see if this file ends with .hl, which happens to be the file extension type for Hyperlambda. If it does, it executes this Lambda object. This Lambda object loads the file. Then it transforms it into a Lambda object. And this little bugger here at line 14 actually ensures that comments are preserved. Then it does the opposite, preserving the comment, and then it's saving the file. If we go down here to line 13, now we can actually modify our code. At this point, we want to do remove -nodes :x at hyper to lambda /*of.ticket.verify. Now, what do you think is going to happen when we execute this code? Pause the video here, read through the code, and try to imagine what the result of this is going to be. Now, assuming you pause the video, I'm going to click execute. Then I'm going to expand tools. Then I'm going to open up HyperID in a different tab. Then I'm going to go to my modules folder, choose Northwind, and open up the category /count. And of course, everything went completely wrong. It just completely deleted the content of every single file I had. So let's CRUDify all tables again because there was a bug, and now we have to overwrite the existing module. So let's CRUDify all tables again. Let's go back to HyperID. Let's open modules. Let's open Northwind. Let's open up categories count.get.hl, and remember this line of code. And then let's go back here. And instead of doing the minus iterator here, we're going to do at hyper to lambda, which of course is going to end up being slightly more intelligent than the stuff we did previously. If we now go back to HyperID and notice this line 19, we close the file, we open it again, no line 19. So we actually created a computer program that went through potentially thousands of files and actually edited those files for us dynamically and semantically. This isn't like some regular expression exercise. This is a semantic edit of our code. Let's further continue now. But before we do, let's save this snippet. Let's call it tutorial 02-03 because it's our third snippet in our second YouTube video. Click save, and then let's remove this line and let's instead do insert -before :x at hyper to lambda /*data.connect, and let's execute the code. And now notice carefully here, line 17, as we close this guy and we open it again, and nothing happened. So why didn't it happen? Let me see. Hyper to lambda all insert before, yeah, because we didn't actually insert anything. Of dot ticket function control space verify admin root guests foo -bar function F5 to execute the code. Let's close the file again, open it, and ta-da! We now changed the authentication or authorization requirements for every single Hyperlambda that happens to have an invocation to data.connect at its root node's children. And this could be one file, or it could be a million files. So we actually created a computer program that actually edited our code. Now let's save this snippet. Let's call it tutorial 02-04, click carriage return, and we now have 4 snippets. Yet again, there's a link in the description of this YouTube video to an article where I'm going to be publishing all of these snippets, but I do emphasize that I want you to write out this code manually yourself, pause the video, maximize the code here, at which point it should be easier for you to actually see the code and manually write it yourself because of this tactile memory type of thing. So now to repeat, we have created Hyperlambda that actually concatenates existing function objects, creating one function object of them. We have created a Hyperlambda snippet that actually dynamically opens up potentially thousands of Hyperlambda files and actually removes function invocations from those Hyperlambda files. Then we have created a Hyperlambda function object that actually opens up potentially thousands of Hyperlambda files and dynamically inserts new Hyperlambda at a specific position in the pre-existing Hyperlambda, given a specific condition, being, of course, that the data.connect invocation actually exists. And that is it for this video. Remember to like, subscribe, hit the bell, share the video with your friend. Thank you for watching. Have a nice day.